Okay, so let's get started. So if we take a look, we're looking at page, it says complete the topic. Oh, we already did that. The I can't statement, use triangle congruence to understand kites. This is day one. All right, so this first thing it says, Manuel is designing the kite-shaped keychains for the debate team. He draws kite PQRS with line QS as the line of symmetry. He makes a list of conclusions based on the drawing. So if we look at this, his conclusions are PR is perpendicular to QS. So we're stating PR is perpendicular to this. So this is providing it will actually let me draw. There we go. Is a right angle. QP is congruent to QR. So they're saying this is congruent with that. SP is congruent to SR. So this is congruent with this. Wait, wrong one. Sorry. Step it back. No, it's S. Oh, no, wait, I had the right one. Sorry. I did. And they're saying PQR is an equilateral triangle. So P to Q to R, they're saying this is equilateral. And PSR, so P to SR is isosceles. All right, so the question here is, which of Manuel's conclusions do you agree with and which do you disagree with? All right, so if we take a look at this, what do you guys think? So what do we agree with? What do we disagree with? Yeah. Actually, PSR does end up being isosceles. However, what about PQR? Do we think that that's an equilateral? No, that's isosceles also. A kite is actually two isosceles triangles, but with different leg lengths. Okay, put together. The rest are good. Like I said, the only two things we don't see is PR bisects QS. So here's PR bisecting QS. There's no way that's a thing. Okay, and the fact that QR is an equilateral triangle. So what other conclusions are supported by the diagram? In this case, it would be PQR is an isosceles triangle because we have these two congruent sides. Okay. The other thing we know is that PQS, so P to Q to S, this triangle right here, this larger one, I'll highlight it for you guys. Okay, is going to be congruent with R to Q to S. So these two halves end up being congruent. We can get into more details of that with proofwriting and solve. Yes. Oh, I feel the eye rolls. Wait, what? Yeah. I told you we weren't done. Nope. Yep. We still have to prove similar triangles. Bro. Yeah. So, your triangle congruent statements are still valid. Everything we've done so far, from topic 1 to topic 4, and now we're adding more into topic 6. It's all still valid, guys. Okay. All right. Any questions on this? All right. So now that we know some of the rules of kites, let's move on. So here's our first theorem. This says, we're not going to prove it right now, but if we are given a kite, then we know that WY is perpendicular to XZ, okay? You're going to probably, if you guys look at your foldable, open it up with properties of kites, okay? All the properties are listed here for you. So you have two pairs of adjacent and congruent sides. You have one pair of opposite angles are congruent. Diagonals are perpendicular, and the longer diagonal bisects the shorter diagonal. So these are the four properties. This one is showing property number 3. So you don't have to write it down, okay? But you do have to memorize it.
Are we going to have to prove that something is a kite using all of
A
that?
little bit. It's coming. I'm not going to lie to you. All right, so example 1, investigate the diagonals of a kite. How are diagonals of a kite related? So we have a kite has two pairs of congruent adjacent sides, and we have here in point B is equidistant from the endpoints of AC, as is D. So they lie on a perpendicular bisector of AC. So these are the three that deal with just with the diagonals. So two pairs, again, we have that in our thing. Two pairs of consecutive sides are congruent. Diagonals are perpendicular to each other, and longer diagonal bisects the shorter diagonal. Yes. You don't have to prove okay, so you're wondering if you have to prove everything? You don't. We're going to get into that a little bit later, though. We're not going to do that right this minute. Okay? However, I think the best thing for you to do is definitely prove that the diagonals are perpendicular and that the longer one bisects the shorter one. You're going to need at least two. Oh, does that make sense? Any other questions? Parallelograms are a little different, though. Okay. So head to our workbook, page 138, okay? This is the picture from number 1. I would copy this picture down so that when you reference your notes a little later, you at least know what the heck all this is talking about, okay? So I'll give you a minute. I want you to try these two out, or these three, sorry. Yeah. Sure. Okay. How are we doing on these three? Anybody still working on them? All right. So it says, what is the measure of angle A to X to D? What's it going to be? 90 degrees. Oh, did I say that? Oh, sorry, you're right. A to X to B. My apologies. Nice job, Kira. All right, so if AX is 3.8, so here's AX, it's 3.8. What is AC? What did you say? 7.6? Why am I? Oh my gosh, I'm losing my mind. Here we go. AX, AC. There we go. All right, if BD is 10, so here's BD. This whole thing is 10. BX is 5. What does does BX equal 5? Sorry, I'm reading it wrong. Yeah. Yeah, okay, guys. Last chance. All right. No, you're right, because AC is not a bisector of BD. So this can't be 5. This long one splits the short one, but not the opposite way. Okay? Questions on that? All right. Anybody still writing? Let's take a look at example 2. So here's our quadrilateral. PQRS is a kite with diagonals QS and PR. So what is the measure of angle 1? All right. So in this case, if we look at angle 1, where is angle 1? Oh, there it is. Angle 1 should be 90 degrees. Again, these diagonals are perpendicular. We know this is a kite because these two sides are congruent and these two sides are congruent. So that means that all the other rules apply. Okay. What is the measure of angle 2? Now, if we look here, the measure of angle 2 is going to be found. This is a right angle, so it's going to be 1. Let me write that down below, actually. So this is going to be 180 minus 90 minus 35. Okay, or you could set it up like that. It's completely up to you. Either way, you do get 55 degrees for the measure of angle 2. All right, now what is the measure of angle 3? Now it says since this is an isosceles triangle, I'm just going to highlight it here. We know that this angle and this angle is congruent. So that means the measure of angle 3 is also 35 degrees. You want to prove these? If you want to prove these two, you can prove triangles congruent also. So all those rules can still apply. Let's say they're just telling me, hey, I've only got specific parts of this. Let's say they're saying this is congruent, these two parts are congruent. How would I prove these two triangles congruent? QS by reflexive property, and then therefore both those triangles end up being congruent by side, side, side. Okay? Questions on 2 before I move on? This is actually something very interesting that you guys should probably note. You may incorrectly assume angles are congruent just from the appearance. Always check that you can prove the congruence first, which is another fancy way of saying don't trust the picture, trust the math. Okay? I think we all kind of learned our lesson there with that one quiz, right? Okay, let's try these out. So it says quadrilateral WXYZ is a kite. So they're telling you it's a kite, so all the properties of a kite apply. What is the measure of angle 1? Well, if we take a look here, again, there's our right angle. I'm going to take 180 minus 90 minus 32. So the measure of angle 1 equals what? Is he? 68. Not 68. Yeah, angle 2. Oh, no, this is angle 1. No, angle 1. Yeah, go ahead. 58. So it's 58 degrees. Okay. All right, now for angle 2, if we take a look at this, now, something you guys need to be aware of is that this does bisect something. It bisects the opposite angles. Okay? So in this case, if this is 32, that means this is also 32. So this is 32 degrees. And it's because XZ bisects angle WXY. Questions on that? Habits of mind. We're just going to talk about this. What ideas about triangles have you learned that could be useful in investigating kites? Write down side, side, side. Side, angle, side. Angle, angle, side. Angle, side, angle. HL. Those are the things that are going to help you. Okay? Any questions on this? Now, I'm not going to lie to you guys. Today, in your homework, there are 2 fill-in-the-blank proofs. Okay? Again, that was done on purpose because we need to get back in the swing of things with proof writing, especially once we hit parallelograms. Okay? But are there any questions on this before we... No? We're good? Okie dokie. All right, get going. Those of you watching at home, have a great day.